Thanks for tuning in to Stay Sharp with Razorleaf, your secret weapon for all things digital and products and manufacturing. This episode features a conversation between our podcast host, Jonathan Scott, with Razorleaf's head of products, Tim Noce, where they delve into the complexities of integration in modern business environments. They focus on the importance of data flow, processing needs, and the evolution of integration solutions. They discuss highlights and challenges of building a digital thread, the role of middleware, and the necessity of both synchronous and asynchronous integration, as well as emphasize the need for scalability and flexibility in integration architecture. Tim also shares his experiences when developing Razorleaf's Clover platform. Let's listen in.
So Tim, I'm glad we're sitting down today because I know one of the things we've been wanting to talk about for a while and get to on the podcast is, what do we see from an integration perspective that's important to have sort of in your tool belt, in your experience, to be able to build out digital thread integrations, right? And as our product guy, as the guy responsible for Clover and our integration platform, I want to talk about that. Can we dig into that today?
Certainly, and thanks for having me again. So it's exciting to sit down and start to talk at a little deeper level about the things we're doing, about data and where integration and how all the challenges that we faced and how we ended up with our integration platform and what the pros and cons of what our customers face.
Right. And I can't wait to dig into this because so many customers come to us with questions about integration that, why isn't it this simple? Or what, isn't a digital thread just a series of integrations, those kinds of things? So I'd love to just jump in and dig into okay, so what does integration look like? What do we see most often? So to me, the things that I want to talk about, I want to just talk about, what did we do with Clover? How did we arrive where we arrived, right? Because I remember back in the day doing consulting projects, people were asking for, what you look at now is like simple things. I don't want to enter a bill of material in ERP if I've already entered it in PDM, if I already made it in CAD, that kind of thing. So, is that where some of this starts?
It did, and I think you always start with the simple. There's one specific use case or need that a department or two departments
right.
have that share information without having to rekey, right? So
right.
that's a big part of it, and eventually it turns into something bigger when you're starting to look at across the enterprise workflow and those kind of things. But you start with something simple like that. I don't want to rekey data, or I need a good way of importing data. That can be a starting point.
Right.
I'm exporting and I have this Excel spreadsheet and I need to get that data into this system so I can use it.
Well, so that probably brings up some of the things that you deal with that gets you just incrementally more complex, right? Because what you're doing in the spreadsheet, maybe you could code that. Did that come up for us? Just move here to there was one, but then it was move, manipulate, and then put in there.
Oh, sure.
Okay.
You don't think of how much human processing there is until you start to have those conversations. Mm-hmm. Well, it's not just a data load. The person who's building that spreadsheet or changing that spreadsheet or has some sort of an operation associated with the spreadsheet.
Right.
And that's when you start to look at the data exchange, those are the types of operations that you end up automating and possibly putting in the middle between the two systems,
right.
And essentially emulating that human behavior.
Right, and that's, I'm gonna go out on a limb and talk about a couple of reasons why I think that is. And you tell me, is that right? And what am I missing? One thing that you end up doing there is the data just needs to look different in the two systems, right? We could be talking about a bill of material, and let's assume for a minute that we all know what a bill of material looks like, how it behaves, how it's structured. There's still going to be nuance between where it's coming from and where it's going to, right?
Oh, certainly. It could be nuance. It could just be systems have different types or different lengths of data,
right?
Accept different structures for the data. Mm-hmm. But it could also be that the data itself, that the usage of that data is really just a representation of the data.
Right. So you might need to simplify it.
Sure.
Example?
So
okay.
you mentioned a BOM.
Right.
So a BOM to an engineer is much different than a BOM to a procurement person, for example.
Yep.
Right. Because the procurement person wants to flatten it so they can order quantity and do those kinds of things.
That's a great
example.
Right? There's math, right? That flattening a BOM is an algorithm that you want to apply, and if you want it to look one way in system X and and it comes from looking a different way in the first system, yeah, why not, right? All right, I'm going to flatten this thing. Every level of indenture I have, I'm going to multiply the quantity times the higher level quantity. I'll get a total quantity, and now I've got a parts list.
Exactly.
But you knew how to do it algorithmically, and I assume that's the kind of thing people were asking us for in the middle.
It is, or the opposite of that, Jonathan. So, you get to manufacturing execution system, they want to identify potentially every screw, the location of every screw, or at least every serialized component, right? And where it sits in which piece of the assembly, so that they can track that thing. So it's much more granular.
And that's a tricky problem, isn't it? Right? If you want to go from granular to summarize it, that's straightforward.
Yep.
But this, and again, correct me if I'm wrong, this is where you get as really interesting integration work, because maybe system A has got most of the details, but it's summarized. You want to bring it over here to manufacturing, for example. But system B has a different set of details, and you need to do this before you put it over there. Okay.
Quite frequently. Or everything is in system A, but some of the data is stored as metadata, and other might be CAD representation in a different area of the system, right?
Okay.
So piecing that together, getting all the superset of data that you need, and then shaping it appropriately for the destination can be tricky.
Right.
And you start asking yourself beyond that, what files need to go along with that, what renditions,
right?
Those kind of things. So you might need file conversions, or you might need to take metadata and turn it into file, so that representation of that metadata can be delivered in a different format, not necessarily through a
So I want to dig into one that you said that makes me think of a conversation we had with another friend of ours on a different podcast, right? Talking about being model based. And one of the challenges today when you think about integrating data is you might have some representations that are metadata, like you said, other representations that are inside of a file, right? Lots of the model based work that happens today, to your example, you have a great example, I think, of manufacturing data. I need to know which bolt I'm trying to put into which hole. Not that I've got 26 bolts. All right, that's good. I got the right quantity ordered. That's helpful when I'm moving data across systems to know I need to order 26. But when it's time for MES to talk to PLM and say, this bolt, this one out of the 26 is too short, too long, whatever, to have those two systems talk to each other, you need, say, an instance ID. An instance ID you're not necessarily going to get from a bill of material or a parts list.
That's right.
You're going to have to get that from the CAD data and the model data. And so to do, like you were just saying, to do some of this sharing of data across the digital thread, we've got to take what one data set or system knows, put it together with what another one knows to get it to a third, or the reverse, right?
Or the reverse, or somewhere in the middle, shape the data in such a fashion that you can add those types of things, add the logic to build those other data elements out, or related elements out, so that it's usable at its destination.
So I want to take this to why Clover looks the way that it looks, right? Why when we think about what we put together as a product to help do some of this, I think what you're getting at, right? I mean, as I understand it, is if you're going to apply logic in transit, if you're going to do multiple points pulled together, multiple data sets to then send to a third one, or one data set and split it, or any of those kinds of operations, you've got to do something in the middle. It's not passing data anymore. It's more than that.
Agreed. There's two elements there, right? There's flow.
Right.
So it's the direction and the combination and the distribution of data, and then there's the business rule side of that, which is I need to process that data. I need to do something with it, either before it's transferred, when it's transferred, or somewhere between.
Right.
And so I think that's a challenge for a lot of companies that think that integration is simply move a part from A to B.
Right. Move a file, move some data, that's it, right?
And that's all I'm doing. And I've had customers tell me, why is this complex? I'm just trying to move a label, right? But then when you look at the state of the label that needs to go on that assembly at the end of the process, and the label's changing as well, and there's the label becomes obsoleted in a source system, for example,
Right.
you've got to be able to pick the right data. How do you handle that and let the destination system know and the floor know not to use this label because it just went obsolete when
Right.
when whatever change occurred that caused the update.
To your point, if you want to apply logic that normally was applied by humans, like, oh, don't grab that one because that one's out of date or whatever, then to apply that logic, you need somewhere to apply that logic.
That's right.
Right.
And so your choices are source system,
Right.
destination system, or somewhere between.
And that gets us to, okay, when we started looking at how we would integrate things, I'm sure we did tons of projects. I remember back in the day where it was just connect source to target. That was it. And you picked one language or the other, that kind of thing. And as you, to your point, as you get more complex and you need to do things in the middle, you start to say, wait a minute, is that really the right way?
Right. And we call that point to point, right? You have 2 points. You have your source and destination. You have no middle.
Right.
So you had to code all your logic at one end or the other.
That's not scalable.
It creates a number of problems, right?
Right.
It's simple to do for the most part.
Right.
You're still writing software, so it's not always simple.
Yeah, yep.
Trust me. But you take out a lot of the power, right? You have to run it on a system that may already be taxed,
Yep.
may already be underperforming, may already be too complicated. You have to use that system, either the source system or destination systems, developers who might have different languages, different skill sets.
I remember
coding
these
in different
problems,
ways.
right? I remember
Oh, yeah.
you tried to run it on a PDM machine that maybe was housing the CAD tool because you needed to do something, but then nobody could use that machine or the PDM operation slowed down. I know what you're talking about.
Yeah, and the persistent problem, which is when you present the two teams, the source system, say PLM, and the destination system, say ERP, and you present those teams with the opportunity to build out an integration, they'll fight each other over who gets to do it, right?
Right. Right.
or no, everybody doesn't
Nobody
want it to
wants
be
to do
their
it. Yeah,
problem,
one of the two,
right? And so, but it becomes somebody's problem. It becomes somebody's problem to initially create and then to maintain it over time, and then to evaluate the impact of an endpoint upgrade,
Right.
a system upgrade on that code, and to go back into a dev cycle and do all these kinds of things. And that's where the evolution of integration has really took a turn.
Right.
From let's not make all these point-to-point connections, trying to create a spider web of data exchange, trying to orchestrate which one executes at which time. But let's use a middleware piece with APIs at the boundaries.
Okay.
So that.
And this is how we got to our approach.
It is.
Okay.
It really is. So that's the essence of how we started to build our integration platform. We had a lot of use cases, and we've done integration every which way. We
Right.
still occasionally do a quick
Sure.
point to point for
Sure.
whatever the appropriate purpose is. We do federated looks into other systems and
Yeah.
don't move data. We do a lot of different things. But when it came down to it, we knew had to move files and data between systems. We knew we needed to process the files and data in the middle, oftentimes creating those renditions we talked about or changing things. Sometimes it's not even source to destination. The source and destination might be the same. For example,
Okay. Yeah.
a product changes category and its related document needs to change. Something like this just became more secure.
Mm-hmm.
So
That's a fun one.
that's a fun one, right? So something that was in general design, the next engineer, goes through an approval process and whatever, and now we want to add that information and take the product to some sort of a sensitive state.
Right.
And this is a use case we've worked on.
Yeah. Well, we've got plenty of regulated industry customers, defense, etc. This comes up plenty.
It comes up plenty. So the product change, there's all these documents associated with the
Right.
product that now have to be designated with some sort of a stamp
Yeah,
or
that's right.
watermark or
It's cover page
metadata.
time, it's stamp time,
That's right.
it's- yeah.
And so you might, upon that triggering event, which is the recategorization of that product, you go find the related documents, you pull them out of the system, add that cover page, add that watermark, write the metadata in, potentially put it in a different store, bring it back into the system.
Yep.
So those are the kinds of things that having an integration platform like our Clover platform that can also do job processing brings you.
Yeah.
So that's not a simple, anybody can pass, just like point to point is easy. Anybody can pass some data about a part between two systems, right? There's modern REST APIs to do those kinds of things. But those aren't the use cases we run into.
Right.
We run into business problems, flow problems, data problems that we're asked to solve that are much more complex than just sharing bits of information.
And this is what digital thread development is about, right? I mean, digital thread, as your people are building it out, it's rich with data, but that means it's rich with data in different data models, different systems, et cetera. And that's the challenge people are faced with. It's one of the places I think where we see what we have as A, an integration platform, but B, as a job processing platform built into an integration platform, is the kind of thing you need to build out that thread, right?
Certainly.
Because it's not as simple as let me pass data or let me surface data in a dashboard. It's not that. It's more than that, right?
It is more than that. Let's go back to that same example. I've got a product which has parts and BOMs associated with it, and it has documents associated with it. I just talked to you about adding a cover page. Maybe that cover page has ITAR requirements, handling requirements on it. Where's that information stored? It's unlikely to be stored in the same engineering system that we picked up the original document and the product information from.
Right.
It's probably from a controlled source being written by some other department somewhere else that has, save it out on SharePoint or somewhere. So now you've got two sources of information that you got to go get the data from, consolidate it, process it, and then put it back in or
put it wherever it needs to go.
That's right. Pass it downstream. So looking at those kinds of use cases, you build that. The true thread is that the product, the document, the even potential ITAR security information or legalese that's sitting somewhere else. That's the real thread here, right? They may not be related at this point in time, but at some point in time in the future, they may very well be related in a thread of information.
Right.
So, that, and you take that example and you go all the way down through, all right, now we've got definition, design, and specification, and now you start looking at procurement and manufacturing and the history, the history of not only the product itself, but the operations, the environment it was manufactured in, the machining that was used to do it, all of these components that really make up the true digital thread, they're all related in a digital thread that creates a definition of the product that is beyond the design.
So it reminds me of one of the use cases I think we've seen plenty with customers where they've said, look, I want to be more model-based. And one of the tenets they follow as they go to be more model-based is they make their data more granular in whatever system they're using to manage it, right? So the model contains just the geometric data, the GD&T, whatever that might be. But then, they're making a part of a specific material with a specific coding, those kinds of things. And so that data is in a document, right? That data is in a note, and so these are separated out because we're going to reuse that material note 100 places. We're going to reuse that paint note, those kinds of things. But then you end up with the problem of now they need to translate what inside their four walls is very workable and logical for them. They got a PLM that connects it all, right? They've got to translate that to purchasing, to your point. Downstream, they need to use it somewhere. But they need a way to put it all back together to say, all right, I want to give you a package. I want to give you some kind of output that ties together the pieces of the thread that someone downstream needs. This is that same processing problem, right? You've got to have something to apply that logic.
It is.
To give you what you need.
It is, and so having an integration platform, having the right architecture, putting in a hub and spoke kind of architecture where we make all the connections to all the systems we need to connect to, and then we orchestrate the information exchange, the extraction, transformation, the shaping, the processing, applying the business rules, doing data validation, all of those types of things as part of the overall flow that we're going to create for that product or that element or that data.
Okay, that makes sense. So I want to key up on something you said and just go again back in history a little bit, right? Because I'm talking with lots of folks, lots of IT folks. I get lots of questions about how we do integration, right? How do we do it? What do we leverage? That kind of thing. And you get questions about what about software X, software Y, and approach X or Y. There's some things that in getting there, we probably didn't do. Is there any of that you could sort of, some things that we didn't do or couldn't do or didn't think was the right fit that are worth sort of mentioning, that people commonly come to us and say, well, why not do X?
There are some elements that we don't find quite as important as others. So off the top of my head, the no code or low code pitch.
Right.
That's great if you're doing that simple integration that we talk about, where I can pick pick an object and a few attributes from the source and map it to,
right.
Assuming that it has the same object and attributes.
It sort of speaks to maturity, right? If it's that mature that anybody can do it, then maybe that's an okay approach.
Then the no code, low code approach and platforms, they're great at that.
Right.
Lightweight integration, passing some data back and forth, right? We do support some of that, but only really as a basis for getting to solving the true digital thread problems, which include all the processing of that information, and applying business rules and validating security and anything else that you can think of that might be part of the life of that product data.
But you're not saying that mapping has to be hard and you have to do it all with code. That's not your point. Your point is just if you only have no code, low code mapping, you're not going to be able to tackle some of the cases you're going to run into.
That's right. So our focus, our focus was anybody can do the 80%.
Right.
That is easy, and it's probably it's 50 to 80%. That it's going to be pretty easy. But when you get to that
last 20,
that last 20 to 50%, it complicates things because you need to consider things you didn't consider in your integration before. Okay, adding that cover page and recreating it as a rendition to PDF or maybe a 3D PDF or whatever that is, right? That's a long running operation, and you start to do that over and over. Now you're introducing performance characteristics of the systems. Now you really want that hub because you don't want your PLM
you don't
system,
want a hand
your
system
ERP
A or B
system,
doing it,
having them spin up and generate PDFs all day long, right? So you introduce a lot of other factors when you get to that complexity.
Yeah, and that's where, I feel like it's good for us to talk through this and for people to understand and appreciate some of that thought process that went into how we got where we got to, because if you don't think about that up front, to your point, you can get to the 80% and then you can never get the last 20 done because of whatever approach you took at the beginning.
And looking back, it's interesting because we didn't set out to build an integration platform.
Right.
We set out with a bunch of PLM and ERP and MES consultants, manufacturing consultants, with helping customers and running into problems, and not
collections of use cases.
Collections of use cases that couldn't be solved with anything on the market. We were looking around. We've tried integration platforms and iPaaS systems and low-level data exchange mechanisms, but we were always left wanting.
Right.
And so we always had to code these elements anyway in order to make that operation occur properly across the enterprise. So what we did was collect all of those use cases and sometimes the code that went along with them and built a framework. We ended up with an integration platform because we needed to solve that 20%, and we were solving it with each new client, each new challenge, each new use case.
In a lot of ways, you could look at Clover as it was sort of our evolving toolkit for solving the use cases that we had seen, to the point where we said, wait, the toolkit is ready-made for doing some things just out of the box. You're just ready to go do it. But, it's still got that toolkit aspect that when you need to get the other 20%, it's there. Right? We built that into the architecture.
That's right. We're into our 15th year, really, of where Clover is. It wasn't until 6 or 7 or 8 years ago marketing found out what we were doing and got a hold of it and gave our platform a name, right?
Right.
But it was a toolkit for our consultants to go in with a code base to solve these problems, right? To be able to create those PDFs, to be able to manipulate data in a certain way, to be able to parse hierarchical data out of the source system, things that are tough, validating that the items are downstream before you try and place a bomb into a system that doesn't even have the children parts loaded. You know, those kinds of things, right? Those kinds of elements of sequencing, looping operations,
Well, this is all the
long-running
stuff-
processing, right?
This is all the stuff that that I find myself talking with clients about, with other people about, when they're curious why this is so challenging, what the issues are, and we talk about the character of the data with them, right? It's that kind of thing, that if you understand how the data behaves, then you understand the need for these certain tools, methods, all these things that you have to bring to the table to responsibly move the data or access or merge or blend or do whatever you need to do with the data. That's tricky. And if you don't have the right tools in your toolbox, well, understanding the data is one thing, working with it appropriately is another.
That's right. And the character of the data, I love this concept, right? Because it introduces not only consideration that the data is spread out and distributed and probably among a lot of different systems, as we talked about before, that changes over time.
Right. It's very dynamic.
Time becomes an element in this, and it's often ignored. It's often ignored. Everybody looks at the point problem today and says, oh, I just need to move data from point A to point B. Well, as the systems change, as the requirements change, as the rules change, as the flow needs to change, because you're introducing new things into your business or into your product or into, into your organizational processes, that integration may need to change.
Right. It has to keep up, right? Because like you said, any number of those things change may influence the data on one end or the other, or the multiple places it needs to come from, much less how it's processed in the middle, rules, logic, any of that stuff. And it can be as simple as, a business change, some kind of regulation change, whatever it might be. But if you're not able to go in and sort of adapt, I think is your point.
That's right.
Yeah.
And so when we were building our platform, we looked at these challenges. We looked at the long-running jobs. We looked at the fact that we know change is imminent. There's going to be change that's going to be introduced at some point, and we really looked for an architecture to where we could make these elements. They're not no code, low code, but they're managed code. They're managed code that is modular in nature, that you can build into sequences and flows and change over time. And if we have to insert a validation step because something changed, or we need to swap that one out, to swap out that operation that's pushing it to system A and push it to system B because I've just changed my destination. Those kind of things are all pluggable.
So this is what you mean by managed code. I get it, right? So I'm gonna put an example, like you said, with validation. You got step A is pull the data out, step B is transform it, step C is put it in the other system, right? But then you say, oh wait, hold on, we need to add a validation step. Well, if I can insert that as a step that's modular, right?
That's right.
Then tomorrow when that validation changes, I can swap it out for a different one. But your point is the whole overarching orchestration can stay the same. The endpoints of the systems I'm connecting to can stay the same. It's just the one piece. And that's what you're getting at.
That's what I'm getting at.
Okay.
So imagine you started with a point-to-point operation and you're passing a bill of materials, and then you realize quickly that that code is failing because the children weren't
available or whatever.
Weren't in this destination system, right? Or the units of measure don't match, or the plant number isn't there. Those kinds of things happen. And so you have to build that validation and that logic in. And so you have to either rewrite and update that point-to-point connector, or have a platform that is pluggable, that you can insert that step to do that kind of thing.
To your point, if it's point-to-point, you're ripping out all the code, fixing the code, and replacing that whole piece of code.
That's right.
Where if it's pluggable, it's maybe you even keep running, and you switch over, these jobs are now going to run with this task plan instead of that task plan.
That's right. You're starting to see the advantage of having a platform over doing that easy point-to-point.
Right.
It's easy up front, but now we've talked about, the system endpoints could change, and that causes you to rewrite. The business process might change, or data might need to be validated, or something new is introduced to one endpoint that breaks it, and you're rewriting and republishing and doing all those kinds of things. So that you know, that element of it is, I don't want to say, a must, but it's a that element of it is a natural progression from what you might do initially when you need to feed some data to truly having a digital thread of information and a more mature integration architecture.
So let me take another one that I hear as a challenge that comes up in integration, right? And that's the difference between synchronous and asynchronous, right? So I know we've done both. We've heard plenty of needs for both, but is it possible to do both in the same platform? I mean, how do we deal with that today?
It is, and for our listeners who don't know synchronous and asynchronous.
Good point. We should back up a little.
Yeah, let's take half a step back. So, synchronous being real-time communication, right?
I'm in my PLM. I need a part number. I click the button. I need to grab it from ERP, but I'm waiting. Don't take 10 minutes to give it to me.
That's right. So I need to respond to that request immediately to satisfy a waiting user or a waiting operation, right?
Asynchronous being I could make a PDF in the background, and whenever it gets in there, it's fine.
That's right.
Yeah,
right.
Okay.
So I think probably 80 to 90% of use cases are asynchronous in nature, right? But we do, I think 80 to 90% of use cases are probably asynchronous in nature, in that the user can continue an operation. You have an EC release, and that part information needs to be passed down, or files need to be created or generated or exchanged. Most of it's asynchronous, but there are very specific use cases where you need real-time information. And we've run into those a number of places. The waiting for a part number is absolutely one of them. I can almost guarantee, it's not 100%, but it is near 100% of the time, your ERP system is going to be your part number master. It's your system of truth, because that part is tied to financial information in that ERP system. So
that's right. This gets into a whole CM2 conversation about part identification, but it's exactly right.
Right. So your engineering staff, yes, they want to introduce part numbers into the system, but it's not quite that easy, because they have to be tied to financial aspects and sources and things.
Well, it's when a lot of organizations, this is off on a tangent, but lots of organizations take the time to evaluate the cost of a new part number by looking at the overall cost of the organization over time. When we add one, what does it cost in warehousing and material costs, sourcing costs, all these things, and they say one new part number costs this, so they put a few controls maybe on getting a new part number.
And there are other areas where real-time information can be very valuable. If your object type is video, for example, you want to stream that. You can't have an asynchronous connection.
It doesn't work so well.
No, you need a connection-oriented stream of information coming back to the user, right? So it might depend on object type. It might depend on timing of somebody
use
waiting
case,
for a
flow,
response.
whatever it might be.
Yeah, so it's important that the platform supports both of those types of things. So in ours, we built in real-time proxies so we can bypass the queuing. That queuing for the asynchronous is important, by the way, because you want to make sure that job completes, and if not, that rainy day is handled in that scenario.
That you can go back and re-trigger the job to get it done.
Re-trigger the job, fix it. And we build in a bunch of caching and logic that is turned on optionally, where you can go fix errant data or and resubmit from there. Imagine a big release process where an ECO goes through a month of approvals waiting for whatever executives are to get back from vacation and do their part and vote that thing through, and you get this all done, and then it triggers a data release downstream to ERP for planning and MES for manufacturing planning, those kinds of things, and for some reason it fails. Somebody changed the password on the destination system, right?
The fifth parted line fails, we got to fix it or whatever.
You have a couple of choices. You could try and code that in the source system to figure out if that data completed or not. Difficult to do, right? Very difficult. You can ask for a re-release of that EC.
There's a whole lot of human effort involved in that, right?
Time and dollars, right? That is not something you want to do. So that queuing and that orchestration and that being able to validate that the operation completed, that the data is where it needs to be, and
or recover if it didn't.
If it didn't, be able to reprocess, pick up, fix the password, hit reprocess, and have the operation go through. Those are the kinds of things that have an integration platform.
But I think you brought up a great point in there, that the ability in one integration platform to do both, to say, I've got all of the capabilities and techniques I need to do the real-time piece, and I've got all the capabilities, supporting logic, facilities, all these things to do the asynchronous piece. Great. So, and the reason we have this is we've had both use cases, so we needed to cover both.
That's right.
Yeah.
That's right. So, and you start to think things, so we're going to get complicated now. We're going to get fun. So now take this, we're talking about this as if these systems are all sitting between you and I.
Right.
Imagine if they're spread across the world and you're dealing with latency, or you're dealing with local language, or you're dealing with
security models.
Security, right? Different security models.
Right.
Different security models, different identity providers for systems, those kind of things. So when you add that aspect to the character of this data, you start to realize that it's not quite that easy.
Right.
It's not quite that easy, and you might want to distribute the processing of this to local vaults or to local geographies. You might want to scale. You might need to scale. So as we took that code that we built for all these use cases and turned it into a framework, we made all these considerations that we're going to have to scale up and scale out as necessary to achieve performance requirements, or to distribute systems to local geographies.
And this is the kind of stuff that went into the architecture and the design of the platform, right?
That's right.
I mean, when we were working on, well, yes, we've got a lot of things we've done. We have a nice toolkit, but how do we put that together in a way that is the best package that's reusable, that covers the simple case, right, in a non-complex way, but yet can scale out and is modular, scalable, extensible, all those things to the complex cases you were just talking about.
Right.
That's what we had in mind. Yeah.
It is.
Okay.
Not necessarily in mind. I'd love to tell you I had a moment of enlightenment, and I sat down.
It was all part of the master plan.
Yeah, master plan. No, but it was lessons learned over these decade plus of doing this, right? And became pretty obvious. So we made changes, and we continued to improve, and we continued to add things to the platform we do today. So,
right.
There are a lot of elements of this that will change, and having a platform architected like ours that we can update frequently, that we can, we're getting an underlying architecture now where we can deploy things rapidly and add new features and extend the plugins, the capabilities to connect to new systems, even homegrown systems and things like that.
Right.
That's all important in building an environment that will be there 10 or 20 or 30 years from now.
You're getting at the pieces of like, well, we understood what the suite of capabilities needed to be and how they needed to work together. But to your point, then as we started to bring that together, we also recognized the things that would make it easy to deploy, easy to update, easy to change, because we knew, to your point, the product was an evolution of what we saw in the real world, and we know it's going to continue to evolve. So how can we be efficient about that?
Yeah, and I'll give you a couple examples. So we knew right off that we needed to be able to let clients write their own code, or be able to add these methods to do all these different things that we know we're going to be asked, but we don't know that they are yet.
Well, I know one of the areas that we focused on was just the deployability of the solution, right? The ability to deploy a solution that could be scaled up, it could be scaled out, could be easily managed, could be modular in terms of how our engine worked, right? So, Tim, talking about all this, it's clear to me whether it's Clover or not, right? Because we're using Clover as an example, but I think, the general conversation is, what have we learned about integration and building out digital threads for people that we know is important, whether it's our integration platform or someone else's? And there's lots of lessons we've learned. Right?
There is.
I mean, that's what really I'm hearing from what you're telling me.
It is, and I get questioned all the time, why is Clover different? Well, I've told you a little bit today about why it's different, because we came at it from a different approach to solve things that were difficult to solve with other platforms.
That weren't getting solved by some of the ones that were on the market.
But the truth of it is, Razorleaf is different,
right?
Because we bring that knowledge, that skill on integration, on digital thread, on digital twins, and flow, and
it's the pattern recognition.
It's the pattern
use
recognition,
cases we've seen.
Use cases we've seen, and that's what's driven the platform that we put together to be what it is. So you can acquire another platform. You may have to build that from ground up. You
Right.
still need that expertise in order to do those kinds of things. So our focus in design engineering and manufacturing has really given us something unique in the marketplace.
Right.
Thank you for being here and listening to this episode of Stay Sharp with Razorleaf. If you have any questions, please just leave a comment on our post or send us an email to podcast@razorleaf.com. We'd love to hear from you. And if you like this podcast, please hit the like button and subscribe to our podcast on your favorite podcast platform or on our YouTube channel. Until next time, stay sharp.